Guys, we are still on our exponential equations. That's still on our exponential equations. But this time, you might wonder what type of an exponential equation that we are now having. What is it that is happening? Why are we having fractions this time? Last time, we just had a condition that is direct. And also, in our previous, if you check properly, in our previous exercises, x was on the exponent. 2 to the exponent of x is equal to 8. I make the bases to be the same. 2 to the exponent of x is equal to 2 to the exponent of 3. Because this number and this number, which are the bases, are the same, I equate my exponents. I'm going to say these two are equal. X will be equal to 3. That was the situation. So if we check this time, it's a little bit different because this time x1 is in the denominator. I mean, in the base. Our base is the one that is carrying the unknown. And 2, we have a fraction. Okay, what type of an equation is this? We are still on our exponential equation, like I said before. So how do you solve this type of equations? Okay, this is what you're going to do, guys. Provided that we are given a certain number, a certain variable raised to a certain exponent to give us a 5, like the first question. What you do is that you get rid of that exponent. Because already x, we see it. We see the x is already there on the base. What we just need is to make sure that it must be raised to the exponent of a 1. Why? Because any number, when raised to the exponent of a 1, it remains as it is. So if x is being raised to the exponent of a 1, it remains as x. So what does it mean? It means that in order for us to have a 1 here, okay, because there's a half, it's not a 1, we must have a 1. So what do? We introduce the reciprocal, all right? The reciprocal, all right? Remember that the reciprocal is simply the inverse of a certain number, okay? The inverse of a certain number. And if I'm given a fraction, like if I'm given 1 over 2, the reciprocal of 1 over 2 means 1 over 1 over 2, which is a 2. Okay, which simply you interchange that fraction. So the reciprocal, I mentioned about this to say the reciprocal of A over B means B over A. You just interchange your fraction. That is the reciprocal. So what you do is that you are going to raise each exponent that we have on this part by the reciprocal of the exponent that we have, the reciprocal of the exponent. So if you do not know the reciprocal direct to say the reciprocal of 1 over 2, it's a 2. Just use your calculator. Like I said, the reciprocal means 1 divided the inverse. So the inverse means 1 over like this. That's the inverse. So it's the inverse of what? Of 1 over 2, which is 1 over a 2 like this. That's we have got the inverse of this number, which is going to give us a 2. So it means that if we raise this to the exponent of its inverse, what's going to happen? If we raise this x to the exponent of a half that we already see, which is to the exponent of a half like this, if we raise it to the exponent of its inverse, which is its inverse, which is its reciprocal, which is 2. What will happen? All right? Before we talk about that, let us raise 5 also to the exponent. Remember, it's an equation. Whatever that you do on the left-hand side must be done also on the right-hand side. Okay, so this is an equation. So whatever you do here must be done that side. We raised by exponent of 2. We raise also by the exponent of 2, which is the reciprocal of this exponent. Okay. This is what is going to happen. Remember, we want to get a 1. So it follows that a number which is A over B, when multiplied to its reciprocal, remember we said the reciprocal of A over B, which is the inverse of A over B, you simply interchange this, okay, which is going to be B over A. So it follows that a number, when multiplied to its reciprocal, which is this one, b over a, we get a 1, okay? This will cancel, we get a 1. So meaning to say, we're going to have x to the exponent of a 1, which is same as what? Which is same as x. That's why you have to look for the reciprocal, which is the inverse, because here, if you multiply, because you can see that there's an exponent here. So if you multiply a half and a 2, we're going to obtain a 1. That's x to the exponent of a 1 is equal to 5 squared, meaning to say 5 times 5, which is what? Which is 25. So x to the exponent of 1 is x. So remember, we said x to the exponent of 1 is same as what? Is same as x. So that means x there must be equal to what? To 25 in order for us to get a 5. So that means we can also prove this is an equation. Remember, I said everything about equation can be proved. So you can take this value of x, we put it here. Remember, our x is 25. So it means 25 to the exponent of 1 over 2, that is 1 over a 2 like this. You're going to get what? A 5, which is the same as this 5 that we see here. So that is how we can also prove this. Your left-hand side must be equal to the right-hand side when you are proving this. Okay, number 2, we have the same situation or the same scenario. So just going to apply what we did on number 1. Okay, this is one and the same thing. We just need the inverse there. So that's going to be number 2. X to the exponent of 1 over 3 is equal to 2. What is the inverse of 1 over 3? The reciprocal of 1 over 3. So like I said, if you do not know this, you divide by 1. But the reciprocal of 1 over 3, you interchange this. So it's 3 over 1, which is what? Which is 3. Or you simply divide, okay? On your calculator here, that's 1 over, that's the reciprocal, okay, of 1 over 3, like this, 1 over 3, like this. Just going to close your bracket, which is a 3. So the reciprocal of 1 over 3 is a 3. So what do you do with the reciprocal? You raise every exponent, every term to the exponent, everything that you see to the exponent of the reciprocal. So that's x to the exponent of 1 over 3 to the exponent of its reciprocal, which is 3 over 1 or just a 3. And you also do that on 2, you raise it to the exponent of 3 also. So that means here you're going to multiply a third and a 3, an exponent to an exponent, a to the exponent of m to the exponent of n is going to give us a to the exponent of mn. We multiply m and n. So we are going to multiply a third and a 3, which is going to give us a 1, which is equal to 2 to the exponent of 3, which is 8, 2 times 2 times 2, 3 times, that's an 8. So therefore, x is equal to 8 in that case, okay? So that was going to be the value of x, which satisfies this. You can also prove, substitute 8 there, raised to the exponent of a third, you must get a 2, okay? So that is how you can answer these questions. Number 3 is one and the same thing also. If we try number 3, we're going to see that it's one and the same thing. It's the last part, just going to find the inverse of this number. So that's number 3. We are given x to the exponent of 1 over 4, which is equal to 1. So what is the reciprocal of 1 over 4, or the inverse of 1 over 4? So the reciprocal of 1 over 4 is a 4. So you're going to raise this x to the exponent of 1 over 4 to the exponent of a 4 is equal to 1 to the exponent of a 4. Or like I said, if you find this, you can just use your calculator. That's the reciprocal of 1 over 4. You're just going to put this, substitute there, put a 4 like this, going to have 1 over, we're going to have 4. So that's the reciprocal of 1 over 4. And if you multiply 1 over 4 times a 4, like I said, an exponent here is affecting an exponent. So you multiply the exponent. So that is going to give us what? A 1. So x to the exponent of a 1 is equal to 1 when being raised, whether to the exponent of 1000, whether it's to the exponent of 100, whatever number that 1 can be raised to, it remains as a 1. So therefore, our x was going to give us a 1 in that case. Okay, so that is the value of x that is going to satisfy this equation. So this is the same situation that we are seeing on these questions, question 4, question 5, and so on and so on. All right, if we check on question number 5, they just changed this to put 2, but it's one and the same thing. X to the exponent of 2 over 3 is equal to 4. So like I said, there we just need the inverse of what? Of the exponent that you're given. There's 2 over 3. So what is the reciprocal of 2 over 3? So the reciprocal of 2 over 3 is 3 over 2. Just interchange this, all right? That's the reciprocal. Just interchange tip over, so that's 3 over 2. Or just use your calculator, 1 divided by 2 over 3. Your calculator is going to give you 3 over 2. So that's your reciprocal. So you raise everything to the exponent of the reciprocal, okay? So that's x to the exponent of 2 over 3. The one that we have here, we raise it to the exponent of its reciprocal, which is 3 over 2. We do that also to 4, so it's going to be 4 to the exponent of the reciprocal, which is 3 over 2. Whatever that you do on the left-hand side must also be done on the right-hand side. So that is how you can simplify this, okay? So like I said, whether it's a multiplication, guys, as long you deal with the what? A number to its reciprocal, you're going to get a 1. So that's 2 over 3. When multiplied to 3 over 2 is going to give us what? It's going to give us a 1, or you can just use a calculator also. So that's x to the exponent of 1 is going to be 4 to the exponent of what? Of 3 over 2, which we can simplify this. What are we going to have here if we simplify? 4 to the exponent of 3 over 2, that's 3 over a 2 like this, okay? This is going to give us an 8, so that's 8 in this case, okay? So therefore, x here was going to give us 8. In the long run, that's what we're going to have. And if you substitute this value of x here, we must get this value, which is what? Which is 4 in that case, okay? So that is what they just tried here. The same thing on question number 6. I want you to try that also. Question 6 or question 7, question 8, question 9. Just one and the same thing. But on question number 9 there, as you can see, there's something that we need to do before we talk about the reciprocal of the exponent. Here there is a number that we just need to get rid of. Okay, let me just remove this so that we can talk about number 9 here. All right, so if we check on number 9, we've got a number that we have to consider there. It's 3x to the exponent of 5, which is equal to 729, like this. So if we are to solve for x here, we are going to see that there, 3 is affecting our x, okay? 3 is affecting our x. So what do? We can divide by this 3. We can also divide by this 3 here. Okay, this one is a multiplication, so you can divide by 3 to get rid of that 3. So you can divide by 3 both sides. So this will be x to the exponent of 5, which is equal to 729. Now we divide by 3 to get the exact value before we even talk about the inverse. Get rid of the numbers that need to be simplified together, all right? So that's 729 divided by 3, which will be 243. So that's 243. So the question is, can we find the inverse of 5? Yes, possible. The inverse of 5 is 1 over 5. Now we can determine the inverse. Remember, the inverse is simply 1 over that number. So it's 1 over 5. So it's 5. So the inverse of a 5, 1 over 5, just like that. Okay? Remember, 5 is same as 5 over 1. So the reciprocal of 5 over 1, we interchange this. So 1 is going to be written on top. 5 is going to be written down. So it's going to be 1 over 5. That's the reciprocal. So we're going to raise everything to the exponent of the reciprocal. X to the exponent of 5 raised to its reciprocal, which is 1 over 5, is equal to 243 raised to the exponent of 101 over 5. So here we've got 5 exponent and exponent, we multiply. So 5 times 1 over 5, that's a 1. So x to the exponent of 1 is equal to 243 to the exponent of 1 over 5. So this is 243 just raised to the exponent of 1 over a 5. So this is 1 over a 5 like this, which is a 3. So you're going to have our x being equal to 3. So like I said, if we are to prove with this x value, we put it there on the original question, we must get the answer that is equal to the right-hand side from the left-hand side. All right, so these are the questions. Just try the ones that I did not attempt it there so that you see if we are together, if you are not together, if you substitute the value, like I said, you can prove, all right? Whatever value of x that you're gonna get here, let's say you solve this one. You substitute your x there. If you do not get 128, that question is wrong. Let me know about that. If you do the same thing, you do not get 32, it means your answer is wrong. So let me know about those questions that you see that your answers are wrong so that we can redo those questions together. But let us check this type again. We are still on our exponential equations and still working with fractions, but this is a different scenario at all. Okay, what is different about this? This time, we have a sort of an expression. Let us consider to something that we are used to, okay? Let us consider something that we are used to. Once we see three terms, we're talking about a trinomial in that case. So we think of ax squared plus bx plus c is equal to 0, a quadratic equation, which is from a trinomial, a quadratic trinomial, where we can work it by factorization. So meaning to say, if I can have a certain term being raised to the exponent of x, the exponent here, the variable being raised to the exponent of 2, I have a quadratic trinomial, which can be solved by factorization. So what I need is to ask myself on these exponents, because they are different, is there an exponent that I can use, okay, as the smallest one, and use that exponent? Maybe I've got, I want you to see this. Maybe I've got x to the exponent of 1 over 3. And if I raise this to the exponent of a 2 like this, it means it was taken from x to the exponent of, this is ms of 1, 2 times this is 2 over 3. So where I see something like this, x to the exponent of 2 over 3, I can think of rewriting it that way. By rewriting it in this way, it means I have a quadratic term, because a quadratic has to be raised to the exponent of a 2. So I have a quadratic ax squared plus bx plus c is equal to 0. So I have exponent of 2 there. So if I can do that, guys, I'm done, because I now have a quadratic that I can solve by factorization, because we understand that if I have something of this nature, x squared plus 5x plus 6 is equal to 0 like this, as long the coefficient here of x squared is a 1, we can just have two brackets that you're going to consider, okay? Focus on this term, okay, which are the factors of 6 that you're going to need. You add them to give you a 5. Which factors do we have there? That's 2 and 3. Okay, this is just a revision. We talked about this. When I have 3 and 2 or 2 and 3, we add here, then we equal to 0. So if you keep this in mind, you are not going to have a problem, because on this one, you're going to have something of this nature. Maybe it's x to the exponent of a third, like I said before, to the exponent of 2 like this here, and plus 5 here, x being x to the exponent of a third, plus 6 is equal to 0. If you check this part that we have here, this one, which is the one that we are used to, and this one are the same. They are just written in the same way. Take a closer look. This one, x to the exponent of a third, is same as this one, x to the exponent of a third, which is the same situation here, x to the exponent of a 2, and we've got x. So we've got x and x here, this x and this x, but this one is being raised to the exponent of a 2, which is the same thing here. This one that we see here and what we see here are the same, only that this one here is being raised to the exponent of what? Of a 2. So it's a quadratic just like this one. So if we are to consider that this one is same as we've got a 1 here. So like I said, on your factorization, you are going to have two brackets there, just like this part. But what is going to be inside the brackets? Let's consider what are you going to have. We want to take it from what we understand like this. So you're going to see that there it was x here. But now it's no longer x, it's x to the exponent of 1 over 3. So we are going to have here x to the exponent of 1 over 3. Here also, we are going to have x to the exponent of 1 over 3. Remember our quadratic trinomial. Okay? Once you have that, you focus on the constant, which is 6. Which numbers are you going to multiply to get a 6? You add them to get a 5. You are back now to the numbers that we got, which is, we said 2 and 3. Why am I writing a 2 here? We said 2 and 3, not 2 and 2, but 2 and what? 2 and 3. So meaning to say here, we are going to have a 2. Here, we are going to have what? A 3. We're going to have a 2 there and a 3. Then we solve just like what we could have solved here to say x plus this is equal to this, x is equal to minus 2. We do the same thing, or x is equal to minus 3 on the other side. It means the same even here. We are going to take it that way. It means this bracket must be equal to 0. So x to the exponent of 1 over 3 must be equal to transpose 2 to the other side. It becomes a negative 2, or x to the exponent of 1 over 3 on this one, transpose 3 to the other side, it becomes a negative 3. The difference now, I want you to be clear. The difference that you have is that here you have solved to the last term. Here you have solved, you're done. You have your x values. But here you do not have x values, no. You are still having x being raised to a certain exponent. So if you take closer look, you are now back to these ones that you're solving here before. X to the exponent of a third is equal to this, x to the exponent of this. So how do you solve such exponents? Because we talked about these ones before. We said these ones, we are going to find the reciprocal of the exponent. We raise everything to that reciprocal. So here we talk about the reciprocal of 1 over 3. Which is the reciprocal of 1 over 3, we interchange is 3 over 1, which is what? Which is 3. Or just use your calculator. 1 divided by what? By 1 over 3. We get a 3. That is the reciprocal of what? Of 1 over 3. So you're going to raise everything, but take note this time, these numbers, as you see, they carry negatives. So this is how you simplify it. It's going to be x. Like I said, we raise to the exponent of the reciprocal, all right? And the reciprocal there is a 3. So you're going to raise this to the exponent of a 3, also this to the exponent of a 3. That's how you do it, okay? This one to the exponent of a 3, this one also to the exponent of a 3. So by doing so, we are getting the value of x because we're going to have a third times a 3. 1 over 3 times a 3, which is same as 3 over 1. It gives us what? A 1. And x to the exponent of 1 means what? Means x. So here we are going to get x, which is equal to negative 2 to the exponent of a 3. Remember, 3 is an odd number. So if you raise a negative to an odd number, we get a negative, okay? 2 to the exponent of 3, which is 8. Or you can just use your calculator if you're not so sure about that, because there you're at the last stage. You just need the answer for the final mark there. So even if you use a calculator, no problem, okay? We do the same thing here, the x and the third and x and the 3. They're going to cancel just like what we talked about. You're going to remain with x. Then we've got a negative again, raised to the exponent of a 3, which is an odd number, which is going to be a negative 3 to the exponent of a 3, which is 27. So it's going to be negative 27. So as you can see, we are obtaining now the x values, just like here to say x is this or x is that. So the difference that we now have, this one was a direct quadratic equation that we can see. This one, we call it a disguised quadratic equation. It's a disguise, it's a quadratic equation, but it's being disguised. It's just a normal quadratic equation, but they just disguise it in a way that we might think it's not a quadratic equation. But all these equations that we are seeing here, they are quadratic equations, these ones, under exponents. These are exponents that when you solve them, they will give you a quadratic equation. So how do you solve them now? If you are given or any condition that the exponents are different, you work with the smallest number, okay? So on a condition like this, you just try it, okay? Because this one, as you can see, one at the first. So you can try to say, if I raise 1 over 4, I mean like this, because I want a condition of x to the exponent of a certain number here, all right? If I raise it, it's going to give me x to the exponent of a half. So I just ask myself, because I know it must be to the exponent of 2, and the number that I'm having there is 1 over 4. So if I'm saying x to the exponent of 1 over 4 like this to the exponent of 2, am I going to obtain 1 over 2 there? Okay, so if you multiply 1 over 4 times 2, do you get a half? Yes, you get a half, which is 1 over 2. So meaning to say that can be written as a quadratic equation. Let us try and see what I'm trying to, let me show you what I'm trying to say. 1 over 4 like this. Remember, an exponent, you multiply, you don't raise it to the exponent of 2, no, you multiply by 2 like this. So what do you get? A half. So it means wherever I see x to the exponent of 1 over 4 being raised to the exponent of a 2, it is the same as what? It is the same as x to the exponent of a half. And this is what I see here, x to the exponent of a half here. So I'm just changing this to be written in terms of this one, so that I form a normal quadratic equation. So that is going to be given as x to the exponent of 1 over 4 to the exponent of what? Of 2. Now we have as a quadratic equation, okay? Minus, this one is going to remain as it is, minus 7x to the exponent of 1 over 4 plus a 12 is equal to 0. So now we have a normal quadratic equation. Yes, we can solve this by introducing a certain constant in place of this x to the exponent of 1 over 4. But what you can simply do is that, since you can see that these two are the same, and it's a quadratic, is being raised to the exponent of a 2, you're talking about a quadratic trinomial. So by factorization, it means this one, since it is multiplied by 1, I'm just going to have 2 brackets in this case. Remember your factorization, that's like what we did, guys. And these are the ones that you're considering, okay? Because it's same as x, but this one being raised to the exponent of 2 means we've got x to the exponent of 1 over 4 here. Also, we have x to the exponent of 1 over 4 here. Okay, so you consider the factors of what? Factors of 12. 2 numbers that you multiply to get a positive 12. If you add those numbers, they will give you a negative 7. Which numbers? You think of 4 and 3, which is actually fine. But these ones, if I multiply them, they give me a positive. But if I add, they give me a positive, not a negative 7. So what do I do to get a negative? I'm just going to introduce negative, okay? Remember, negative terms, negative is a what? It's a positive. And if we add minus 4 plus minus 3, that's a positive, okay? So that's a negative 7. If we add these two numbers, okay, you're going to get a negative 7 in that nature. So these are the two numbers that we want, because they give us a negative 7 also if we add them. But if we multiply these two numbers, they give us what? They give us a positive 12. So these are the numbers that we're going to take here, a negative 4 and a negative 3. So what does it mean? Remember, it means that this bracket must be equal to 0. Also, that one must be equal to 0. X to the exponent of 1 over 4 minus 4 must be equal to 0, or x to the exponent of 1 over 4 minus 3 must be equal to 0. So throw this the other side, okay? Just throw this minus the other side, it becomes a positive. So x to the exponent of 1 over 4 is equal to 4. Throw this also the other side, it becomes a positive. So x to the exponent of 1 over 4 is equal to positive 3. So we are back now to that condition to say, in order for me to remain with x when I'm given a fraction on the exponent, a fractional exponent, I find its reciprocal, its inverse. So what is the reciprocal of 1 over 4? That is 1 divided by 1 over 4, which is a 4. So the reciprocal of this is 4. We also raise this to the exponent of 4. So you can just open a bracket if you want, but that one is just a positive, so there's no need. You also raise to the exponent of a 4 to the exponent of a 4 also there. By doing so, guys, I said you are obtaining the x value, because you're going to have 1 over 4 times a 4, which is a 1, and 4 to the exponent of a 4, which is going to be 64. Or you can just use your calculator here. That's 4 to the exponent of what? Of a 4. 4 to the exponent of a 4, sorry, to the exponent of a 4 here, like this. That is going to give 256. Where am I getting? Oh, Jesus, I'm checking to the exponent of 3. This is 256. So you see now the importance of having your calculator can help you to prove such, okay? Then the same thing here, x is going to be cancelled there. 3 to the exponent of a4, which is 3 to the exponent of a4, which is 81. So sometimes your mind might be tied up. So that's why you have to also prove with your calculator. But you guys, you're still young for your minds to be tied up, okay? Can't say you are tired at your stage, okay? You're always fresh. So I expect you not to be tired like us guys. We are now having those minds which get tired, but you guys, you are the generation to come. So your minds, they are still sharp and they cannot be tired. So avoid mistakes, okay? That's what I'm trying to say, avoid mistakes. So anyways, guys, this is what you're gonna have. And that's how you can simplify such typical questions. You just have to revise as much questions as you can, working with the reciprocal of a certain term, how to deal with the reciprocal of a certain number, this and that. These are the most important things that you need to understand. So I want you to revise as much questions as you can, whether it's a half or whatever that you're given. And sometimes you might be given an x like this number last that we see here is a different type of those ones. We've got x minus 9x to the exponent of a half like this plus 18 is equal to 0. So how do I solve this? If you have to check this type of an equation, it's still one and the same thing, just like the previous part. If we just raise this a half here to the exponent of a 2, it gives us a 1. Remember, we want to form a quadratic, and this x represents x to the exponent of a 1. If the exponent is not written, it means there's a 1. But like I said, if I raise a half to the exponent of a 2 like this, it gives me a 1. Remember, half and the 2 reciprocal, I mean the exponent to the exponent you multiply. So a half times a 2, that's a 1. We are back to the normal state. We are not changing anything. Take note there. We are still maintaining the same equation that we had. The only thing that we are just doing is to write in the same way as this one, the x to the exponent of a half. So this one just remains as it is because now we've got this to the exponent of a half. So this is plus 18, okay, plus 18. Okay, so you're going to have plus 18 is equal to 0. So as long as these two are the same, we can do our factorization in that case equal to 0. So as you can see here, we have got a 1 on the coefficient of this part that is being raised to the exponent of what? Of a 2. So meaning to say, we're going to have two brackets with x to the exponent of a half, another x to the exponent of a half. So what are we going to do? We consider the constant now, which is 18. What are the factors of 18? We need two numbers that we're going to multiply. They give us 18, these two numbers. If we multiply these two numbers, they will give us 18. But if we add these two numbers, they must give us a negative 9. So two numbers that you multiply to get 18, probably we think of 6 and 3, which is fine. But these here, if I add them, they give me a positive 9, not a negative 9. So what do I do on these numbers? I simply put a negative here, so that negative times negative, true, is a positive. And if I add these two, negative 6 plus negative 3, I get a negative 9. So these are the exact numbers that I want here, negative 6, negative 3. Okay, so one of these brackets must be equal to 0. So if you understand this, there's no need for you to rewrite x minus 6 is equal to, no, just x to the exponent of that. Transpose this, throw it there. If you throw it that side, it becomes a positive there. Or you do the same thing, x to the exponent of a half must be equal to this one thrown that way. It's going to be a positive there. It was a negative, but cast it there. Throw it over the equal sign. As long it jumps the equal sign, it becomes a positive. It changes its sign. Now we are back to the reciprocal because this is x, but being raised to the exponent of a half. So we just need the reciprocal of 1 over 2, which is a 2. So raise this to its reciprocal, also this to its reciprocal, then to 2. Everything raised to the exponent of 2. That's going to mean we've got x to the exponent of a 1 if we multiply here, which is same as x. 6 to the exponent of a 2, that's 6 times 6, which is 36. Or here, we're going to multiply a half and a 2, just like the previous case, guys. This part, you're going to get a 1. So that's x, which is 3 to the exponent of a 2. That's 3 times 3, which is a 9. Or you can use your calculator, like I said. Sometimes your mind, you might be just tied up. But like I said, you guys, I don't expect your minds to be tied up. You're still very young. All right, so this is it, guys. This is how you might be given questions like this. So this was our question number 6. This one, that was our question number 6. So if you just given an x there, you consider the next term. How is it given? Sometimes, okay, but most of the times this is how it's gonna be. Now I wanted to explain something that is in grade 12. Okay, let me not talk about that. I'm gonna talk about that when we reach that level. But for the meantime, let us work with these typical questions on these equations. Let us try as much questions as we can, work with question papers. Where you have a challenge, let me know on this exercise, on some of the questions that I did not attempt, so that we'll work on them together on our next class. But for now, guys, that's it. From Maths Zone African Motives. Okay, some actually they don't like, it's Maths Zone, like this, African Motives, African. If you check properly on the name of the channel, you'll see it, because this, like I see some of the times, I don't know how you guys